Another day, and sunlight washes the waiting earth. Soil, the earth's living skin, forms a thin veneer between the unweathered rocks deep within the earth's surface and the atmosphere above. Soil, the most complex biomaterial on earth, is vital for the existence of life. The sunlight does not penetrate far into the soil, and mere inches below the soil surface, the morning brightness fades into a darker world. The ultimate twilight zone, the world of soil. This world is silent, subdued, but certainly not devoid of life. Let's look at soil from the macro perspective of humans, or more precisely from a ground squirrel that bounds across the grass. The ground squirrel sees a leaf that it can use in its underground nest. Delighted with its find, it zooms underground into the mysterious bowels of the earth. Now let's see how this world of soil arises and look at soil from the micro perspective, where we can see its individual components. At its very core, soil consists of inorganic particles, sand, silt, and clay. Here is a single clay particle, about 1 micron in size. The clay particles are the smallest and are colloidal in nature. Even a teaspoon of soil can contain billions of clay particles stacked one upon another. These clay particles naturally induce electrostatic interactions with nutrients and are the engine that drives chemical transformations within soil. But there are larger particles known as silts. A silt particle dwarfs even 100 clay particles. Larger yet are the sand particles, massive in comparison even to the silts. All three size ranges, sands, silts, and clays, become intimately mixed and bound to one another to form an aggregate of soil. Within the aggregate are voids or pore spaces, originally filled with air. Multiple aggregates join alliances together to form the basic soil matrix or soil architecture. Between the aggregates, larger spaces of soil pores occur, likewise filled with air. The formation of our three-dimensional soil skeleton is well underway, but more ingredients must be added before we have a real soil. One ingredient is water, essential for all life, including life within soil. After a rainfall, soils become saturated, and all pores become filled with water. When the rain stops, the soil drains under the influence of gravity, leaving only a few pores filled with water and some water films that partially cover the particles. The remaining pores once again become filled with air. Soil is a dizzying array of particles stacked and intertwined into clumps or aggregates. The voids in between the aggregates are secret pathways known only to its mysterious underground inhabitants, the microbes. Ah yes, the microbes. Too small to be seen with the human eye, and yet more numerous than the stars in the sky. Just 1 gram of soil contains billions of microorganisms. Viruses, the simplest of biological entities, exist by attacking other life forms. Viruses that infect bacteria and fungi inhabit soil crevices. Bacteria 1,000 times larger than viruses, with a myriad of colors, can be found everywhere, and yet less than 0.05% of the total soil volume is occupied by microbes. Fungi and actinomycetes, massive in comparison to bacteria, entwine around soil particles. Protozoa lurk in waiting for unsuspecting bacteria, which are then eaten alive as a food source. Helminths or worms introduced into soil also have their place. Overall, the fraction of the soil surface area covered by soil microbes is similar to the percent of land area on Earth occupied by humans. The immense numbers and diversity of microbes allow for biochemical transformations essential for human and animal life. Now let's go back to the leaf taken underground by the ground squirrel. The leaf attracts the attention of the soil microbes, who view it as a treasure chest of food. Collectively, they devour most of the constituents of the squirrel's leaf. Microbes can also degrade organic wastes and pesticides, cleansing the soil of toxic constituents. Microbes grow and multiply as they use oxygen for respiration and release carbon dioxide. The remains of the decaying vegetation add to a stable organic debris within the soil, known as humus. At the same time, positively charged nutrients are released into the water film and interact with negatively charged clay particles. Some nutrients are sucked up by plant roots. These nutrients are essential for the growth of plants and are absorbed by plant roots. Thus it is the soil itself which allows for the growth of all vegetation and all crops worldwide. There it is, the world within soil, invisible to most observers. People rarely notice soil. They don't realize that it is essential for our continued existence, and they are unaware that it controls our health and well-being.